Cool.
Thank you.
Awesome. Thank you very much. First off, we want to say thank you to the Ottawa User Unity Group for having us and asking us to do this talk. We definitely want to thank Microsoft for hosting. It's pretty awesome. And thank you to all of you for coming out so that we're not talking to an empty room, because then that would just be sad. We're already doing a technical talk, so it's kind of sad as it is. A couple of things we're going to go through. We're going to talk a little bit about us, just so you understand where we're kind of coming from when we're talking about native plugins. Then we're going to talk about native plugins in general. We're going to go through some examples on how to build them, going through some simplistic examples. And then Jacob actually put together a demo specifically for this talk that's a little bit more real world and actually useful for today. We'll talk about some best practices that we've kind of run into as we've gone through and learned about doing native plugins and have been using them for the past 2-ish years or so. Some gotchas as well. And then finally, we'll wrap things up. So about us. So we're a small company here in Ottawa. We're a services for hire company. So we basically just get contracts from clients to do various work. We specialize in rich interactive games and experiences, but we do kind of anything. It's really whatever people are going to pay us to do, that's kind of what we do. And along with that, we kind of run into some unique challenges. There's lots of different platforms we got to hit, lots of different things that we got to do or integrate with third-party plugins and that kind of stuff. And so that requires us to get really good at a certain code base, but also need that flexibility. And so Unity has kind of been our primary tool for doing that, just because of that flexibility. So I'm John Keon. I'm one of the founders of Karman Interactive. Started up with Mike Baker, who's sitting over there and does not want me to call him out whatsoever. We started up in 2012. We just kind of worked on Skype in our closets, essentially, for a long time. But we now have a little office in a rundown 3-bedroom apartment off of Elgin. So, you know, we're getting there. We're almost there, but we're not quite there yet. And then I just like that GIF, so I put it in. And Jacob is one of our senior developers, and he's going to be doing all the hard technical bits right now. So a little bit of our work. We did a lot of augmented reality books, specifically with Incredibooks for Disney. So these are just augmented reality books. You'd buy them, you'd show them with your kids, and at certain pages you'd put them down and you'd open up the app and be able to go through like these fun experiences and then go back to reading the book. So the kids are always on the devices anyways. This is a way to get them to also read at the same time. Moshi Monsters is a coloring book, so same type of thing with augmented reality, but this time we kind of extended the standard set of features. You end up coloring in on the coloring book. We use the camera to get that information, then we texture the models with whatever you've drawn. So the kids' drawings come to life, and you get to play with it, as well as doing the standard coloring book activities. We also did a game for Sony called Tiki Rush for the PSP and Sony Mobile. Sony Mobile is dead, so we don't do that anymore. And this is kind of an example more on the app side of things. So Publishers Clearinghouse is one of our big clients. This is called PCH Front Page. It's basically a newsreader app. You get your news, you can check the weather, your horoscopes, that kind of thing. And it's kind of gamified. You win tokens, and I think you can trade those tokens in for things on their site later on. But same type of thing, like all of this is all just using Unity, using our frameworks that we've kind of developed over the years, and we're able to hit these different types of markets with our products. And then finally, we're also kind of going and experimenting with wearable tech. I'm not sure how I feel about it as a consumer, but for developing, it's pretty cool. So we did a watch face for Hyperflow, and this one was kind of cool where you take a selfie of yourself, and we analyze the color data in your outfit, and then the watch face reflects that so that it matches your outfit, so that you're never unfashionable with your watch face choices. And then finally, it's a little dark, but we've been experimenting with some Vive prototypes. So we've made a fireworks desert blast. So in the open desert, there's a whole bunch of different fireworks. You set them up, light them off, make your own little fireworks displays. And that is currently in review on Viveport. And I need to wait for, I don't know, their tax people to say, yes, you are a company on Steam, and then it'll be out on that as well. So now we're going to talk about native plugins, which is the reason why we're here.
All right, cool. So Unity is definitely an excellent tool. It provides a ton of functionality right out of box. But sometimes maybe you have some code that you have in another project that you want to reuse, or maybe there's a third-party library that you want to use, but it's all based in C++ or C, or maybe you've identified a chunk of code that could probably use some optimizations on the C++ side, so you want to port that over, or maybe there's some OS-specific things that you want to tap into that Unity just doesn't expose to you. So with all these scenarios, plugins are an option. So here's a quick summary of the types of plugins and what platforms use them. So we pretty much have two groups: managed plugins, which are C# or Java-based. And we also have native plugins, which are C, C++, and you could also do them with Objective-C. So depending on what you're going to be doing, what platform you're going to be targeting for, you're going to be doing one of these things. So tonight we're going to focus on the C++ C native plugins. However, this process is pretty similar, and it will work for all the other ones. OK, so managed code, unmanaged code. We'll just quickly define what these terms are. So managed code is code that is managed by a common language runtime virtual machine, CLR for short. In our case, it's Mono. This runtime is a layer that sits on top of the operating system, and it provides things for us like memory management, garbage collection, type safety checking, stuff like that. Unmanaged code is code that is compiled down to machine code, and it gets executed directly by the operating system. The code that's traditionally used here is C, C++. Unmanaged code is typically faster. However, there are some trade-offs that you have, such as you have to manage your own memory, garbage collection, stuff like that. And you're definitely more exposed to crashes due to buffer overflows or pointer overrides, stuff like that. So you definitely have to be more cautious and have tests, thorough tests. OK, so building a plugin. So we're going to run through a very simple example just to get an idea of how to use a C++ function inside from C# code. So how do we do this? So the first thing, we'll quickly run through making a DLL on the using Visual Studio, and then we'll make a bundle using Xcode, and then we'll see how to do that, how to call the code from Unity. OK, so first step, open up Visual Studio, create a new project, select Win32 application from the C++ section, give it a name. You're going to want to select a DLL from the application settings, and you're going to want an empty project. Next, once you have that, you can create a source file. You're going to want a CPP source file and give it a name. And then once you're here, you could put in some code. So first thing that you're going to want to do is write an extern C block. We'll talk about this later. And then any function that you want to call from Unity will go in here. You also need to prefix the function with a decal spec DLL export. We'll talk about that in a second. So that decal spec DLL export, it's a compiler-specific attribute. So it just lets the compiler know that we're going to be taking this function and exporting it from the DLL. And then once you've got that all set up, you can compile. And depending on if you're making a debug build of the DLL or a release build, it'll be in one of these folders in your project folder. So next, we'll quickly go through the steps on the Xcode side. So keep in mind
Sorry,
that
Microsoft. Sorry.
That's okay.
Right.
Just to let you guys know, Visual Studio for Mac announced.
Yes, that's true.
That's true. I haven't used it yet, but I'm looking forward to it. So keep in mind that when you're working on Windows, you're going to want DLL, Mac OS bundles. If you're going to be targeting both platforms, you're going to need both for your project. OK, so here we're just creating a new project on Xcode. We're picking bundle. And then this is going to be a similar process for iOS bundles. Again, fill out your project details like the name. Then create a new file, select C++, give that a name. You don't need header files, so you could check that option off. And then we're ready to put some code into here. So again, extern C block, just so this function is visible from C#. So for bundles, you don't need the decal specs DLL export like you did in the DLL, on the Windows side. So don't worry about this. OK, and then once you're ready to go, you could build, and then you'll have a bundle in the product section. And then this, you could just drag it over into your Unity project. OK, so now that we know how to make bundles and DLLs, we're going to dive into Unity. OK, so first, if this is a new project and it doesn't have any other bundles or DLLs or any plugins, you're going to want to make a plugins folder. And then you just drag and drop your DLLs or bundles or whatever right into this plugin. In this example, I have both. So again, this project could run on both Windows and Mac. I also like to double check to make sure that the settings are right. Sometimes they don't come out correctly. So here, depending on what you've built and what architecture you're targeting, you're going to want to review this section. Same thing for the DLL. OK, and then once all that's set up, we're ready to write some C# code. So first things first, we have to make sure that the C# code is aware of our plugins function. So you do this by declaring a DLL import, stating the name of the plugin, and then you just state the function signature. Make sure to add the extern keyword, otherwise the compiler won't know that you're talking about a function that's outside of your C# code. It'll think that you're talking about a function inside C# code. Once that's all done, you could call your function. So in this example, we're just calling mult. We're putting in some floats, and we're getting back a result that's calculated on the native side. The result is then logged to the Unity console. Another tip, so notice on line 10 that we don't state the plugin's name specifically, the file extension of the plugin. And if you're wondering about the if-defs, we'll talk about those quickly at the end. And here's our result. So
We verified it is correct, so it's good.
OK, so now that we know how to make a plugin and how to call the native code from C# code, we'll take a moment and look at some examples just to get an idea of how to pass data in and get data out from the native side. In these examples, I'll show the C# code on the left, and on the right, I'll show the C++ native code. So here on the left, we have a couple of floats, A and B, which are being passed into the C++ function, just as we're making a regular function call in C#. C++ then takes that, calculates our product, returns it back to C#. And then in this case, we're just taking that result and printing it out. So the nice thing is also you don't have to rely on returns. You can also just pass in parameters by reference, and then you can modify them on the C++ side as if you're dealing with pointers or something like that. And then you'll get the result back in Unity. So one thing that's important to realize here, that since you're dealing with a pointer, you have to dereference. Just remember to dereference your pointers. Otherwise, you'll be actually modifying the address space, the address of the result, which will lead to unknown behavior, but most likely Unity will crash. So if you have lots of data, that's not a problem. You could also pass arrays. So in this example, we're just creating an array of 1,000. We're filling that array with random numbers to save space. I omitted the actual code that initializes all those elements. So it's definitely happening. To do this, we define a function so we define a scale function on the C++ side, which will accept the array, the constant, and the size of the array. And we just pass over our array over. So one thing to note that on the C# side, we're treating the array as just an array, so the parameter has the square brackets. But on the C++ side, we're, since arrays are pointers, we're just having a pointer there. And then, again, we're just looping through that, indexing it, and multiplying it by a constant. I'm also passing in the size here because, unfortunately, in C++, you don't have all those extra helper functions that give you like information on array size and lengths and stuff like that. So I'm just doing that for ease. OK, so those were just the basics. It doesn't stop here. You could also pass things that are more complex, like structs. So at the top on the C# side, I've defined a struct called myVector. And I have 3 floats in there, x, y, and z. So when we're passing objects to unmanaged code, we need to define the layout of the object. So in this case, we're laying out members sequentially. So the order that they appear on the C# side is what we're going to get in the native side. So on the C++ side, we also define the struct just so we know what we're dealing with. And then just like the previous examples, you just pass it in and you could use them. So here we're calculating a dot product of 2 vectors. So in the previous example, we had our own custom struct, but you could also use the Unity vector 3 structs. So here I'm pretty much doing the same thing, except I'm using vector 3s right from Unity. Again, on the C++ side, you just have to define your structure, and then you're good to go. Yep. So this is helpful because then if you had, let's say, some mesh in your 3D scene or whatever, you could interface it directly instead of copying over a vector 3 to a myVector and then passing it in to C++. OK, so we looked at passing data in, getting some data out. But we also want a way to know what's going on the native side. Maybe if you want to know some progress that's happening or if something succeeded or failed, we could also pass function callbacks. So in this example, I wanted a way to log messages from the C++ side as they're happening. Maybe I'm debugging something, or I don't know. So here at the top on the left on the C# side,
C# side, sorry.
Yeah. Oh, sorry, not the top, but down in the actual function, I have a function called custom logger.
Somewhere in here, between these 2 bracks.
Yeah, somewhere in there, I have custom logger. It's at the bottom.
Yep,
this
right
is
here.
our function that we want to expose to C++, and this will just log a string to the Unity console. On the left, at the top, we declared the type def. Sorry, on the left, on the C# side, we have the delegate.
This guy.
Yep. And this is the signature of our custom logger function. Next, on the C++ side, we have a function called set log callback. And here we're passing in our custom logger function. And we also define a type def to reflect the
This one was easy to find.
the signature of the C# function that we will be getting. And we're also keeping a static variable to the function, which is log msg. Then when we just call set log callback, and we pass in the function that we want it to keep a reference to. We do that like that, and we just call it from like that start function there on the C# side, and we pass custom logger. And now anywhere we want to call this function from the native side, we could just call log to Unity, and it will shoot out the message, which is very handy. So let's quickly talk about the speed. So in this example, I'll be sorting 2 arrays that will be the same size, and they'll contain identical random elements at the same positions. Then we'll perform a sort on the array A on the C# side, and we'll also be sorting array B, but on the C++ side using std sort. And here's a quick summary of our results in milliseconds. So you could see that for small array sizes, both took less than 0 milliseconds. The first difference is noticeable at the 100,000 element size. So here on average, I was getting around 1 millisecond for the array sort on the C# side and 0 milliseconds to sort on the C++ side. So this is very negligible, but however, the runtime does increase at the 1 million and 10 million mark, where the average of the array sort on the C# side took almost 3 times as long than the C++ side. OK, so that was just a quick example. It doesn't reflect the type of problems that we run into on a daily basis, which leads us to our demo.
It's demo time. OK, so with this demo, we wanted something that's a real-world example. Obviously, arrays are used as examples all the time, but no one ever ends up actually sorting things every day. It's kind of the same thing as when you do the textbook problems in the math. Like, you've never gotten a job and your boss has come to you and said, got this new textbook, there's no answers in the back, go, right? It doesn't happen, right? So we wanted to find an existing C++ library that would do something useful within the context of game development, and it had no C# port. So we couldn't just grab the C# version of it. We found one. It's got a lot of code. I actually tried to port it to C#, and I gave up because it would just take forever. And so we thought this is a great candidate to hook up as a native plugin instead. So the idea here is that you've got your 3D asset that your modeler has created, and it's a relatively complex form, but you want it to have collision, and you want that collision to be accurate. So you could go and you could painstakingly take a whole bunch of primitives. You could take your cube colliders and your capsule colliders and all those kinds of things and kind of mush them all together so that you sort of have the outline of it. But if your artist ever changes this, it adds like 2 more engines on the side and a bunch more tails, you're going to have to end up recreating that. Unity has a mesh collider, and you can attach it onto your mesh, and it works. But it only works for convex meshes. So if you have any sort of aspects where you have dips in the mesh, which makes it concave, it doesn't work. So if you select the mesh collider and you say that it is convex, you're going to get something that looks like this, where it basically gives you the largest outside perimeter edge of everything. So you can see here, even though there's blank space, if we were to shoot something at that, it would still hit here and register as a hit, which is not accurate. So we found this plugin called VHACD, and it's just freely available on GitHub. And basically what this guy's done is you can pass in any mesh, and it will go and it will decompose it into the smallest set of convex hulls. So it's basically taking this camel, it runs through, and it basically breaks it down. And we've got this piece. We're guaranteed that this is convex. We're guaranteed that this is convex. And it brings those back so that we can use those as our collision volumes. So Jacob's going to go and show this live.
OK, so here I have the ship that we just saw. And you could see that it has the mesh collider. And I'm just going to run this real quick. Oh, I hope it doesn't crash. OK, perfect. So I have like a bunch of balls that they're going to drop and react to this shape.
Real world problems, right?
Yeah. So I'll just show you real quick. So here, if we come in a little closer, you could see that the balls are starting to react, and they're going to go down this slope over here. And then these balls, instead of falling right through where you would expect in this empty void here, they're just going to roll off and follow this collider here. So that's what's happening.
Not ideal.
Yeah. So to contrast this, here's our demo with using the VHACD plugin. And we have all these convex hulls here. And then just so you could get an idea of how it decomposed this object, here's just a copy of the mesh, and we just painted it so you could see all the individual parts. And then so when we look at it at the individual mesh colliders as a whole, you could see that it's a better fit overall on the entire object. And then when I do that same demo again, you could see it's definitely reacting a lot better with this object these balls are just going right through. And then if I resume this, you could see like that's falling off the engine very nicely and stuff like that. So the code to do this, I'll show the C++ code real quick. So pretty much it's the same building blocks that we talked about earlier in the presentation. So here I'm just declaring some structs just to help me pass data back and forth. Oh, whoops. Oh, God. OK, there we go. OK.
That's bigger.
That's much better. Yeah,
OK, so again, so we have a couple structs here that I've defined that they just help me pass data back and forth. Here's a structure that pretty much these are all the settings that VHACD exposes to us. So you could like play around with like how tight the convex hulls are going to be to the actual mesh. And then literally it's just a couple of functions that I've set up here to call the various different little parts of the library that this guy wrote. So here I'm accepting those vector 3s, the array of all the points, all the triangles. And then here I'm returning the convex hull. Just because this library just uses a flat float array, I decided to make the conversion here on the C++ side because it was faster than iterating the list, the vectors on the C# side and flattening out that array. And then on the C# side, here I define all the functions that I want exposed. I have a struct here that's similar to what we have natively, right here. And then here's pretty much the main function that we're using for this. So it just runs through setting up our parameters, processing the mesh. So it's calling this function down here. If anything weird happens, we just abort. And then we process all the hull data that we get back. And then we just loop through that and create the meshes and the colliders and stuff like that. So I'm just going to revert back to the other setting. I'm so glad that worked.
Could have been bad. Yeah, so again, just to recap, we had a cool mesh. We wanted to have mesh collision on it. By default, out of the box, we couldn't get that. And we knew that potentially our artist was going to change this at some point, so we didn't want to have to do it by hand. We wanted to have an automated way, so we were guaranteed we always had a good mesh to work with. Finding this plugin, we again looked at the amount of source code that came with it. We could have spent the time to convert it all to C#, would have taken forever. It took Jacob just an afternoon, basically, from scratch to port this plugin, or not port the plugin, but to write the plugin to access this library. And it was way faster. The other good thing about this is that this library is already tested. It's already been used. Other people are using it. If we went and ported it ourselves, there's no guarantee that we're not going to introduce some sort of weird bug or we're going to mess up the port in some way. And then we're going to find out later on down the line, maybe right before a deadline or something like that, and then have to spend hours going through and debugging in like a high-stress situation. So we get speed. We get speed to market in that we didn't have to write it, and we're guaranteed the same robustness as whatever it was on this GitHub. So, and we can look at the reviews and that kind of thing and sort of get a sense of how many people are using that. So now we're going to talk about best practices. So having done this for quite a while, we started off doing iOS and Android plugins, basically because back then all the ad networks and things like that hadn't created Unity plugins yet, so we needed to wrap them and expose them so that we could actually use them. And then since then, we've started doing desktop plugins and all that kind of stuff. It's basically the exact same formula. It's not a big deal, but what it does mean is that you need to understand what your problem is. So before you go and start writing your native plugins, try and figure out, do I have a ton of data, and does that data live on the C# side, or does it live on the native side, and which place is better for it to go? Do I need this to execute really fast? If we go back to the array example, if I know my array is only going to have 100 elements in it at the worst case scenario, there's probably no point in making a native plugin for it. On the flip side, if I know there's going to be 1 billion elements in it, then maybe it's a good candidate for wanting to do it native so that I get that extra speed. Also, Unity is a game engine and it works. It doesn't, pretend to know about all the things that it's running on. But maybe you do need some sort of specific operating system or hardware level feature that Unity doesn't expose, in which case is a great candidate for using a native plugin. Like we were talking about, the multiply function is obviously overkill. There's no reason why you'd ever want to go and make a native plugin for one silly multiply function. But at the same time, you technically could go and take an entire other game engine that runs in C++, and you could launch it from Unity, render and do everything on that side, and then pass that back as a render texture and just put it on a quad and have it rendered in Unity. Again, I don't know why you'd want to do that. You technically could, but it's overkill the other way. You're also going to want a profile. So making sure that there's a need, like I said before with the array example, when you run into that speed hitch, then go native to get that speed increase. You're also going to want to watch your memory. Marshalling data across can be expensive if you're doing copies. So just make sure, like in our examples, we're kind of just sharing that memory. And because we're in this little sandbox for this presentation, we know we're not going to mess it up and we know we're not going to do anything bad. But if you just are copying it straight over, then you're doing that every single frame and you're sending your entire world state. That's going to be super expensive as well. So some other methods of passing data back and forth. There's the Marshal class in C#. This is kind of a utility class to help you pass things back and forth. There's a ton of good information on this. I would recommend reading about it, especially if you're going to do something that's a little bit more robust or advanced, especially if you're going to make a native plugin and you want to put it up for sale in the asset store. You're going to want to make sure that your stuff is safe and not going to crash. When we were doing this one, we're just doing it quick and fast and loose. Definitely ran into a few crashes, which is fine for us because we have the code and we can just develop and iterate. If we had put this up for sale, then people would obviously get understandably pissed off. Also, all of our examples here have been synchronous. So we're making that call from C#, it's going into C++, it's doing its thing, it's coming back. Sometimes you may have something where you want to send data you create the data on the C# side, you send it into the C++ side, and then you want to come right back out and let the C++ stuff do something over time. If you do that and you come back to the C# side, and then that C# function is done and that memory goes out of scope, then it's candidate for the garbage collector, and your C++ side's still using it, but the garbage collector doesn't know about that. So you can use what's called gc.pin. Just lets the garbage collector know, hey, we're using this externally, and then when you come back, you gc unpin it, and then the garbage collector can pick it up again. Int pointers, another C# thing. Basically, it's just make sure that if you're on a 32-bit or a 64-bit platform, you're going to have the right size of pointer. Again, in our example, we knew what hardware we were running on, so we could just pass the pointers naked for simplicity. Otherwise, you might want to use an int pointer to make sure that you're targeting the right platform. And then finally, there are two functions on texture, and oddly enough, texture 2D. I don't know why they're not on the same one, but they're not. And that basically allows you to do textures between native side and not native side. So the first one, called get native texture pointer, basically means if I've created a texture in Unity, I can get the pointer to that texture, and I can pass that out to the C++ side and let something else on the C++ side do something with that texture, and then have it reflected back in Unity. And then the other one is going the other way. So a texture was created outside of Unity, and I want to bring it into Unity to render. So a good example would be I've got a webcam, and I want to get that image, and the webcam SDK is already providing me that image. I can get the pointer to it. I can send it back to Unity, create a texture 2D using that pointer, and now I've got my webcam feed inside of Unity that I can place wherever I want. And then finally, the Unity code. We really should have added a GIF here. There's tons of space, and I apologize. That was oversight on our.
I did the demo.
Yeah, quick. So when you're using Unity as the consumer of your plugin, you want that person, whoever that may be, it'll probably be you, but still, you want them to just interface with some C# code. They shouldn't really know or care about the native plugin behind the scenes. So they're just going to hit a class. They're going to say, like in our example for the mesh, it's just give me the convex hulls that I want to use. And then under the hood, you'll use your if-defs for if-def on Windows, if-def on Mac, if there are changes or differences, if-def iOS, if-def Android. And then that would call into the various multiple plugins that you've created to do that work for you. And now some gotchas.
All right, so this is probably the fun part. Okay, so so doing stuff natively, it definitely takes a little more time. You need to have some C++ code or a library that you want to use. And then you need to expose those native functions to C#. There can be some challenges with native code, such as debugging. And you can't just set a breakpoint to step through the code during the runtime in Unity. But there are some things that you can do. So for example, like we showed earlier, you could pass a function in from Unity that exposes the debug log function, and then you could put that into your code so you could see what's going on. Or what you could do is you could set up some native test code just to exercise your code before you bring it into Unity. So unfortunately, anytime you make a change to your plugins and you rebuild it and bring it back into Unity, you do have to reload Unity. There is a way around this. Apparently, you could write a wrapper plugin that loads up your plugin at runtime, but I've personally never tried this, so I don't. But apparently, it works. So, what I would recommend is just writing some driver classes to unit test your code. Once you're happy with the interface, and you have that nailed down and you know your code works, I would bring it into Unity. So common things to be careful about when programming with pointers. So you need to be careful when you're allocating memory. Make sure you clean it up after you're done, and also be vigilant whenever you're allocating memory to a pointer inside a function, because if that function pops off the stack, you won't be able to get that back. So earlier we showed some if-defs wrapped around the DLL imports on the C# side. So specifying the plugin name for the DLL import doesn't actually work for all platforms. For iOS and Xbox 360, you write _ internal. And this is the reason for this is that most platforms will load your plugin dynamically. However, on iOS and Xbox 360, they're all statically linked. So all the examples that we showed today, we wrapped our code in a extern C block. The reason for this is name mangling. So here's an example of what happens when name mangling happens. So what it's pretty much doing is just encoding some additional information to the name of the function. So you could see on the left side, I have mult where I pass in 2 floats, and then I have mult that I pass in 2 ints. And in the object file, you'll see that it appends the _ ZF mult FF. The FFs mean that there's 2 float parameters. Same thing for the mult II, that just means 2 integer parameters. So I got this by, I just compiled using the GCC compiler to object code, and then I inspected the file, and I found those. So once we wrap the extern C around our functions, this is what you get in your object code. It just appends a _, and C# is totally fine to find this. It's going to work. The downside to this, unfortunately, is that you do lose out on function overloading. So that's why I have mult for float and mult for integer. So you don't have to wrap all your code in extern C. Just the code that's interfacing directly with C#. So in this example, it's very simple again, but this could easily be a third-party library, just like the plugin that we were using. So maybe there's some functions that you want to expose. So I've created a application bridge.cpp where it has the extern block, and then I have a pointer to the application, and I just forward those functions along. Conclusion. So yeah, Unity plugins, they're not terrible. Hopefully you could see that they can be a lifesaver on a project, and they aren't also that difficult as they seem. But don't leave today porting all your code to native. Definitely don't want that. You definitely want to pick and choose what makes sense. We looked at the basics tonight, but there's definitely a lot more to look into, like the Java plugins. We do have a blog post on our website that goes through creating an Android plugin to use in Unity. There's also the Objective-C plugins. These are going to be pretty much identical to the bundles that we showed, except instead of C++ code, you're using Objective-C. And there's also the texture sharing pointer business that John talked about. There's a really good example of this on the Unity website. They give you a full project that pretty much shows how to do this.
You get to make a triangle. It's pretty cool.
And well, you get to color it too.
Oh, and color it. Bonus.
Here are some references if you're
Again,
you're
for when we
interested.
post the slides.
Yeah, we'll post
You
the
can-
slides.
You can check them out.
So if you have any questions, maybe you don't think of them right away, there's our emails. I'm also on the Ottawa Game Development Slack community. I'm at Jacob, that's at jkeon. If you're not part of that chat, I recommend talking to Mike. He'll set you
Mike will
up.
hook you up.
I'm also on Twitter, but I don't tweet anything, so more of a lurker, I guess. But you could hit me up there too, and there's John. If you don't get my email right, I think we have it set up that it just forwards all emails that are misspelled to my emails. Yeah, it'll get to me, don't worry.
What's your home phone number?
Yeah.
And times he'll be home. So thank you very much, everybody. We'd definitely like to take any questions, comments, concerns that you might have. Before we get to that, just again, a big thank you to Ottawa User Unity Group for organizing and having us out here. And thanks again to Microsoft for hosting the space. Definitely appreciate it. Thank you.